What is up, mathletes? So welcome back, and we're going to talk about these vertical asymptotes here. And a lot of descriptions, a lot of ideas and analogies painted online, and I like them. They talk about how these vertical asymptotes act like, I think the best one I've heard so far is like an electric fence that our graph can't pass through, right? Or else it'll get electrocuted. So what I like to think about it is like these vertical asymptotes being like a crazy old boyfriend or girlfriend, right? They might be attractive here, right? So your graph is getting really, really close, but you don't want it to touch because that's when things start to get dangerous. So these vertical asymptotes here, right? The way I really portray them in class is I tell my students they're like magnets, but unlike magnets that, we click, if I zoom in, we're always going to have some space between these vertical asymptotes, these imaginary lines, and our graphs. So the more that you zoom in and get closer and closer, right? If I were to zoom in here, and as I go down and down, we're going to see that this graph is going to get closer and closer to our dotted line here, but they're never going to cross. All right, so we say that these graphs, as we approach, in this case, one of our vertical asymptotes is x equals -3. So we have our dotted line here, x equals -3. And what we see, this function here, as I get close from the left-hand side, right, as I'm walking along this line here, as I get closer and closer to -3, I get really close. I get really close to this line, but they never actually meet. All right, so that's what a vertical asymptote is, right? We're never actually going to reach, in this case, x equals -3 or x equals 1. But you could see the further I get, right, as I get to as I get to 0.9, I'm going to be really darn close to this line. As I get to 0.95, I'm going to be even closer. As I get to 0.99, I get even closer. And I'm going to get you pick a number, and I could always pick a number that'll get me even closer to this invisible line here. But we're never actually going to touch it, right? Because this height is going off to infinity. And beyond. So it's going to get infinitely close, as you've heard many people maybe describe, but we're not going to actually touch it. So how do I know when a graph has these vertical asymptotes? All right, so there's two types of functions that we're going to see that have vertical asymptotes. One of these functions is going to be a rational function. A rational has a fraction. So we're going to have a fraction, and another function we're going to look at that has these vertical asymptotes that we'll talk about later is logarithmic functions. All right, so let's focus right now on these rational functions. How do I know where the vertical asymptotes are, if there are any, right? Just because it's rational doesn't mean that there's actually going to be vertical asymptotes. But if it does have some, how do I know where they're located? So here's the big idea. What you're going to do, and write this down, is you're going to set your denominators, whether it's one or many, equal to 0. So we always set the denominators equal to 0. All right, and what we're doing is by doing this, we're looking to see what number can I plug in here that's gonna give me a 0 in the denominator. And what's one thing we can't do in math? Well, we cannot divide by 0. So we're finding these places where our graph, these values of x, where our graph is undefined, right? Well, there's nothing there. So that's what we're really looking for. So let's go ahead, and this x plus 3, let's set that equal to 0. And this is going to give us, once I solve for x, that's going to give us one of our vertical asymptotes. And that's why we got this one right here that I'm about to highlight. Right? That's where that one came from. And our other vertical asymptote, this one right here, well, what we do is we have another factor I'll write it over here, x minus 1 squared, we have that equal to 0. But notice, we don't really even need the squared, because if this is 0, 0 squared is going to give me 0. So all we really need to worry about is what's in parentheses there, the x minus 1. We need to know where is that 0. So let's go ahead and solve that right there. So plus 1 plus 1. So you get x equals 1. And that's exactly where we have our vertical asymptote at x equals 1. So there are two vertical asymptotes. So the big story here, when you're looking for these vertical asymptotes, you're setting your denominator, these factors, equal to 0. So big word of advice here, big precaution: if these are not factored, then it's going to be your job to first factor the denominator. And if you're interested in some factoring videos, check out the link below and I'll be glad to help you out. See you next time.